let me get started by introducing myself and then kind of walking through what we plan to cover in this presentation. And then that will help frame, make sure that you guys are in the right place. So my name's Kenneth Hoy. I am currently at Rackspace. Does it say that? It doesn't even say that. I need to put that in. I'm not trying to hide that fact. So I'm in the technical marketing group over at Rackspace, specifically in the OpenStack team. So my job basically is to generate technical marketing content around what Rackspace is doing in the OpenStack space, and then also to go and talk about it. So the reason I'm talking about VMware technology in particular is prior to joining Rackspace, I was actually involved with VMware technologies quite a bit. And when it just, as luck has it, I was the first person really to talk and blog about what VMware was doing in the OpenStack space, to the point that with VMware, we're actually having their SEs read my blog posts to explain what they were doing. Thanks to the fact that I was able to get myself involved with some of the folks in VMware who were doing OpenStack, and they were very open about what their roadmap was. All right, so a few things we're going to try to cover today. I'm going to clarify some things. There's were and still are a few misunderstandings of what VMware is and where it fits in the context of OpenStack. So I'm going to quickly cover those, make sure we're all kind of starting from a level playing ground. And then I'll talk about some of the key differences, why VMware is architected the way it's architected, and why OpenStack is architected the way it is, and how that creates, how sometimes that's a pro when you put VMware together with OpenStack, and why sometimes there's a dissonance in the way things are built. And then I also want to talk about, for folks who may be interested in running VMware technology with OpenStack in some manner, I'm going to talk about how that's actually done and what are some things you should watch for. Because there are some very unique things about the way VMware is interfacing with OpenStack that sometimes folks aren't aware of, and that can give you results that you may not have expected when you deployed it. And then finally, I'm going to give you some resources that you can go to. So most of what I'm sharing are things that I've written about or have talked about in other places, and I've kind of put that all into one or two places you can look at. So, all right. So let's just clarify some things. I'm not going to spend much time here. It sounds like most of you are working with OpenStack, so you understand what it is, right? As basically a cloud platform to manage data center technologies and be able to expose them via an API so that users can provision their own resources. So I'm not going to go into depth on this, but I do want to talk about the fact, and this was a common error when OpenStack first came out. It's pretty important if you're new to this space to know that OpenStack is not a hypervisor and has never been a hypervisor. So actually, when people talk about comparing OpenStack to VMware, they need to be much more specific. Because often I hear people talk about, when they're comparing to VMware, they're really trying to compare OpenStack to vSphere, which is really comparing apples to oranges, right? Because vSphere itself is a hypervisor that OpenStack can manage. So, okay. And then it's also important to remember that VMware is a company with multiple products. And because of that, there are certain products that compete with OpenStack, but there are also products that work and integrate with OpenStack. So again, when you're talking about trying to compare the two, it's important to know what it is, what specific product set are you talking about within the VMware space when you're saying, I want to compare this to OpenStack. So an example, a cooperation is, vSphere, again, is a hypervisor that is support integrated with and can be managed by OpenStack. Also NSX, which is their software-defined networking solution, is something that integrates into Neutron. But clearly, there's areas where they compete, right? And one of the areas they compete in is basically in the kind of the automation space, or cloud orchestration space, where what used to be vCloud and now is vRealize automation It's specifically a competitor to what OpenStack's trying to do in the data center. I bet they do it differently. And again, when we're I find when most people talk about, I want to use OpenStack instead of VMware, generally what they really mean is I want to use KVM managed by OpenStack as opposed to using vSphere in some form. So let's talk about a couple of quickly key differences between how VMware, and I'm going to be talking specifically about vSphere here, because that's what most people think about when they think about VMware technologies and OpenStack. And I'm going to talk about how that's different than the way that OpenStack itself is architected. So VMware itself is actually a very monolithic architecture. So in the VMware space, you guys may know if you're working with VMware technologies, everything hypervisor is at the center of everything, right? The way you provision storage, the way you set up networks, everything is done through the hypervisor. There isn't a lot of APIs for various networking and storage technologies, because the assumption is you're going to route everything through the vSphere or the EXX kind of architecture. So that's very different than the way OpenStack is architected, where the idea here is every component is actually its own sub-project that basically just exposes APIs that are used by the other projects. And so one of the things that happens, and one of the reasons that OpenStack is ideal for a cloud environment is that a lot of tasks can be done in parallel. So you can set up networking, and you can set up the storage and virtual machines in parallel fashion, because those are all using different sets of APIs. In VMware, everything eventually goes through vSphere. So everything's done in a serial fashion, and that creates some interesting issues. So vSphere, for example, doesn't have the same scalability that you can get with OpenStack and KVM, mainly because every time you want to create a virtual machine in vSphere, it has to go through vCenter. And it can only do, up until the recent version, it could only do eight parallel tasks at a time, and they've increased that to 16. But you can imagine, if I can only do 16, bottleneck to 16 parallel tasks, I will only be able to create so many virtual machines so quickly. Whereas OpenStack doesn't have some of those same limitations. Also, if you think about when VMware was created, in EXXI and vSphere, it assumed a certain paradigm for your applications, which was that these applications relied on infrastructure to always be available. Right? If you have your typical Exchange server or your Oracle server, the assumption is the application shouldn't even know that something has failed, because the infrastructure should be able to handle its own resiliency. And so that's why something like VMware vSphere HA or vMotion became a key reason why vSphere took off in the enterprise. If you look at OpenStack, OpenStack actually was designed around as an open source platform at that time to challenge AWS. Obviously, that's I would probably say that it really hasn't been able to challenge AWS, but it used that as its paradigm. And one of the things that you may know about AWS and cloud platforms in general is that the assumption when you scale out is that the infrastructure is prone to failure. Well, there will always be failure when you have when your infrastructure that scales, and so the application needs to handle its own resiliency. And so OpenStack was designed that way. The assumption was, I'm going to sacrifice resiliency at the infrastructure layer for the ability to scale quickly. I'll talk more about that in a little bit. So a couple of things that are similar. So in the VMware space, there's a concept of vMotion, where you can take a set of running VMs and migrate them off to another hypervisor node. And that's typically done so you can do maintenance. OpenStack has a similar function called live migration that works most of the time, not necessarily all of the time. A lot of times it depends on the storage underneath. But but that's still a valid use of that technology. In fact, in Rackspace in the public cloud, we use live migration on a regular basis in order to do upgrades. One thing that OpenStack, and I'm talking about, when I say OpenStack, I mean OpenStack with KVM, because that's a hypervisor that's used mostly with OpenStack today. One thing it doesn't have is the concept of HA, which is different than vMotion. So in HA, basically, you're not migrating a machine off to a set of new machines. In VMware, if you say HA, when a hypervisor node goes down, all the VMs restart on a different node automatically without any intervention from the end user or any scripts that have to be set up ahead of time. OpenStack or KVM doesn't have that facility today for reasons that I want to talk about. One of the things that have to happen, one of the things that are required to make this work is the concept of shared storage, which is why I have that diagram up. So for vSphere HA to work, all the operating system, right, has to live on a storage that can be seen by two hypervisor nodes. That way, when the one hypervisor node goes down, a second hypervisor node can see all the root file systems and bring them back up on a second node. Since OpenStack doesn't have that concept, right? How many are using Cinder currently? Okay, not many, actually. But one of the things that sometimes people don't know is that while Cinder allows you to use SAN storage, what Cinder doesn't do is allow you to make it a shared volume. So when you take a volume in Cinder, one and only one hypervisor can see it at any given time. In fact, if that hypervisor node fails, you actually have to manually, or you have to script the process of essentially detaching that volume and reattaching it, which is something you don't have to do with vSphere. And it's actually a purposeful decision on the OpenStack, for the OpenStack project, not to have shared storage. Because one thing it did not want to do is have the ability to do HA. And the reason he doesn't want to do that is because he doesn't want shared storage. And the reason he doesn't want to do shared storage is there are a lot of people who would say, anytime you have shared infrastructure, like especially something like a storage array, you're basically limiting the ability to scale, because that storage becomes kind of your top limit of your scaling point. Whereas if I have a shared nothing infrastructure, I can scale more quickly and I can scale infinitely, quote unquote. So that's a huge difference between vSphere and OpenStack or KVM. So we talked about that, the vSphere HA. There's a concept of evacuation in OpenStack, where if a hypervisor node goes down, you can have instances restart somewhere else. But again, that's a manual process, and not all the information transfers over necessarily the way you would do in a vSphere environment. So when I explained this, so I just went through a whole bunch of things that OpenStack with KVM can't do that vSphere can. And this is a typical question I get. Why would you want to create a technology like OpenStack that can't even do basic things like VM auto restart? And it's a good time to talk about cloud a little bit, right? So one of the things I always talk to customers about is you let your applications dictate your architecture, not the other way around. In other words, you don't pick a cloud platform and then say, I'm going to force all my application to be able to run on that thing. You actually look at what your application have and then decide what's the best platform to run these workloads on. And in the cloud space, where OpenStack is designed for, it's a very different paradigm than in the traditional application space. Right? In the traditional space, the idea is you want to scale up your work. When your application needs more resource, you basically just add more RAM or add more resources to an existing machine. Whereas in the cloud space, the idea is you just add more machines, add more VMs. So it creates a different architecture than you would if you were doing the traditional approach. I talked before about the need to have the application handle the resiliency. So one of the principles, architectural principles, is that in a cloud world, things will break. It is the larger your cloud grows, the greater the possibility that something will fail, no matter how much you try to protect it. Right? So you can get the best storage array in the world, you can get the best hypervisor in the world, and I guarantee you, if your cloud environment gets large enough, the probability is something will fail. So in the cloud world, in the OpenStack world, we make that assumption, think that things will fail at that point, and so it's better to have applications that assume that failure and design around it, which again is a very different approach than the way what traditional apps running on vSphere would assume. And then obviously this morning, Randy talked about kits versus pet cattles, the idea of disposable versus maybe non-disposable units of workload of VM. So again, in the VMware space, everybody names their VMs. I know people who have virtual machines that they haven't taken down in 3 years, and they can't, all right? Because the business they would lose millions of dollars if that happened. In the OpenStack space, the assumption is you may sometimes cycle off VMs and kill them intentionally just to refresh them. And so that approach basically changes the way you architect your cloud. So again, you favor being able to be elastic, to be able to do self-service and be able to scale out over very controlled environment where only admins can touch the infrastructure and resources, and where you only scale up and you want to protect you want to put everything into the same one storage array so you can protect it. So it's a very different approach. And so if you have those types of workloads and you choose to go with OpenStack, you need to make sure you choose to go with OpenStack, you want to make sure that the workload you're going to put on it matches the characteristics of that infrastructure. I've talked to a number of customers who, because they want to save capital costs, they basically decided, I'm going to take my existing vSphere environment, just kind of forklift it over to an OpenStack and KVM environment. And in almost all cases, it fails because it doesn't provide that level of infrastructure resiliency that those applications demand. Okay, before I go, any questions? Okay, all right. So I mentioned that a lot of customers I've talked to have started talking about the potential of moving off of VMware and using just OpenStack, in fact, mainly because of cost. So the latest OpenStack user survey, for example, the #1 cited reason for people adopting or looking to adopt OpenStack was to save money. Right? I'm not saying that's the best approach to take, but that is the most popular approach, is to take OpenStack and try to save some money, whether it be licensing costs or whatever, or support costs. So then I said there are a number of reasons why people want to use VMware. We really want to still use vSphere even if you're using OpenStack, right? Some of it has to do with, some really good reasons like, hey, let's make sure your workload matches the architecture. So instead of shift and shift everything, maybe you say certain applications should stay on a vSphere infrastructure and other applications can go on my new platform. Also, people obviously have a lot of existing investments that they don't want to throw away. So they may want to say, we'll use both OpenStack with KVM and vSphere in order to kind of make maximum use of the investments they've made. So the question is, can you do both? And this is where I want to talk a bit about what VMware has done to enable customers to use both vSphere and OpenStack together. How many of you know about VMware integrated OpenStack? How many of you guys played with it much? No. Oh, some. Okay. So you guys know it's basically running, instead of running OpenStack on containers, is running OpenStack on vSphere and using it to manage vSphere resources. So that is a valid approach. There are some limitations, which I've mentioned and I'll keep talking about. But it leverages, it basically is a packaging of the way of the code they've already contributed to OpenStack in order to integrate vSphere and NSX with OpenStack today. So the VIO approach is a good one, particularly if you want to use OpenStack and you're okay with the idea that I'm going to use no other hypervisor but vSphere. But if you're someone who wants to maybe look at both, you're kind of using OpenStack as a single point of management, but use it to manage multiple hypervisors, you can also do that, and this would be one approach you could take. So what you see here is there's the OpenStack control plane managing 2 different sets of hypervisors. The compute nodes on the KVM side, each compute node is also a hypervisor node. In the VMware space, you'll notice something a little different, which is the compute node is not the same thing as the actual hypervisor. So you actually have a Linux server running Nova code that is actually talking via a, what they call a vCenter driver to a vCenter server that has some clusters underneath. And we do that because what it does is it gives you a way to get all the benefits and features that vSphere provides while running it underneath of OpenStack. So one of the things that sometimes customers will want to know is, can I just run an ESX? Like, can I run just the hypervisor, no vCenter server, and just have it run along KVM? And right now, you can't do that anymore anyway, because the driver is deprecated. But the reason it was deprecated is because no one was actually using it. Because the way that that driver was written, you had to have 1 compute node per ESX server, which meant if you had 100 ESX servers in your environment, you would have 100 separate management servers running Nova code to talk to those hypervisor nodes. So obviously, that was not a useful solution. So they deprecated that and went with the vSphere solution. And the reason this is the approach, VMware took this approach because if you think about how vSphere works, vCenter is basically the state machine that tracks what's going on across a cluster. And the only way they could, there were really only 2 approaches they could have taken. One approach would have been to take all the code that runs on a vCenter server and somehow run it on a Nova node, compute node, managing the clusters. Obviously, that's not a trivial thing to do. So they took the second approach, which is basically they said, we'll keep the vSphere server and basically have it proxy all the ESX servers underneath talking to OpenStack. So what happens is when let me see, okay. So what happens is when you're on the OpenStack layer and you say, hey, I want a virtual machine and I want it running on vSphere, on VMware, you're actually not talking to vCenter directly or to the ESX hypervisor nodes directly. What you're actually doing is you're making API calls to the Nova node, and then the Nova node actually makes calls out down to a vCenter server and hands off to vCenter, and then vCenter actually creates the VMs and put them somewhere in the cluster. Make sense? So, and in that way, VMware can say, you know what? I've now allowed you to use a user to be able to self-provision VMware VMs, but you also get HA, and you also get vMotion, you get vSAN, you get everything that a normal vSphere environment provides. So one way to look at it is north of vCenter is OpenStack, vanilla OpenStack. Everything south of that Nova node, it's from the vCenter down, it's straight up vSphere. And you manage it like a vSphere cluster. So for example, there are tasks that you typically would do in a VMware environment that you can't use OpenStack for as an administrator. And as an admin, you would still have to go to vCenter, the vCenter GUI or the vCenter APIs to do those tasks. One of them, for example, would be, I think until recently, I think they're trying to change that now, but for a long time, if you wanted to do vMotion, you couldn't actually do that within OpenStack. You have to do that using vCenter, using the vSphere client or using the APIs. All right, So it's a great idea. So you see here, what's happening is it picks. It basically decides that if it's going to be on a VM server, it hands off to the vCenter server and lets the vCenter server decide where to put things. It's a good concept. Oops, let's see. Except for a couple of things. One is what I call the resource mismatch problem. So one of the limitations right now in the way that vSphere integrates with OpenStack is because the vCenter server is a proxy server. The Nova node actually doesn't see the cluster, right? vCenter completely abstracts away those hypervisor nodes. So what happens is what Nova sees is one really, really big virtual machine. It thinks the vSphere cluster is one virtual machine. So every vCenter so you could have multiple vSphere clusters with multiple vCenter servers. It sees every one of those clusters as one single big-ass virtual machine. And so the problem is, the way the Nova scheduler works is, it's going to pick what it thinks has the most available resources to place a VM. So what you end up getting is a situation where actually a KVM server may actually have more resources than any one single ESX server. But because vCenter is telling OpenStack these two 4 gig machines is only one big 8 gig machine, it's going to try to place the workload there. And then at some point, if it tries to, so in the scenario I have, for example, I think it's 2 6 gig machines. So let's say you have a VM that needs 10 gigs. Instead of placing it somewhere, or 8 gigs, instead of placing it on a KVM server that actually has 8 gigs available, it's going to try to stick it into the vSphere cluster because it thinks it has 12 gigs available, even though each machine only has 6 gigs available, and the task will fail. So that obviously is a problem. A second problem is since the Nova scheduler just uses available resources as a way to decide where to place things, you can't. If you let the Nova scheduler just do things by default, it doesn't know that a certain workload should be on KVM versus on vSphere. So you could have a situation where the quote unquote workload goes onto the wrong hypervisor node. So those are another limitation. So there's one way. So the most popular way around that is, besides just using one hypervisor, which is what VMware would probably like you to do, is there's a concept of host aggregates. How many of you are familiar with host aggregates? Okay, a couple of you, right? So a host aggregate is basically a way to group resources and then apply a filter to the schedule. So you can basically group, say, all your vSphere clusters and say, this is the vSphere host aggregate. And then when you provision VMs, you can say, this goes on the vSphere host aggregate. And then it'll basically filter out all the KVM machines and vice versa. So that is probably the best approach to take if you are going to have a multi-hypervisor environment, is to set up host aggregates separate for each of the hypervisors that you have. Okay. Any questions? Okay. So the question was, does the Nova scheduler know about host aggregates? And the answer is yes. So basically, you create what they call hints. So when you pass a command to Nova to create a VM, you basically pass the host aggregate name as a hint. And it'll basically know to pick those specific group of servers. Okay. Any other questions? No. Okay. So a couple of resources. I kind of gave you the high-level overview of things. So if you want more information, there are a couple of places to go. One, obviously, is to go to the OpenStack doc site. There's the configuration reference guide. Basically, the way it has sections for each type of hypervisor and some of the things you need to know to set things up. There's also sections in the guide about how to set up host aggregates, so you can use a multi-hypervisor environment. The other place you can go is I've actually written a series of blog posts that walks through exactly how things work in more detail than what I'm doing today. So you can go there as well to take a look. So the presentation I will put it up on SlideShare, so you'll be able to go to the links if you want. And then if you have questions, you can email me or you can tweet me. So that's probably the best way to reach me if you have a question about how things work in this space. So I think that's it. So before I stop, any questions? Okay. No, it's okay. Yeah.
I'll just project.
Okay. I'll repeat your questions.
Yeah, so back to your original thing, you were talking a little bit about the IP-based storage. Back to your original point, you were talking about NFS. Do you have any opinions for NFS versus Chef or Ceph or any of these other IP-based storage technologies for use within an OpenStack environment?
Yeah, so NFS is good if you need shared storage. I think it's also, so if you're someone who wants to use live migration,
yep,
or if you just want to be able to do host evacuation where you can actually get most of the data, you need some kind of shared storage. In the Linux space, NFS is a good way to go. So we actually, one of the ways we set up OpenStack is to use NFS to provide the root disk instead of using local storage. And that gives people the way to do live migration. I've heard from multiple sources that Ceph has actually been, people have had the most success doing live migration using Ceph. And a lot of it because it's done so much work to integrate itself with OpenStack. So does that answer your question? Okay. Any other questions about VMware with OpenStack or OpenStack or VMware? No? Okay. Thank you for your time. I'm happy to, if anyone wants to come up and have questions, I'm happy to spend some time answering them as well. Thank you.